Okay, hi everyone. Let's start. Today we'll be looking at firstly the linear function. So my first question is that what is linear functions? So can anyone give me an answer? Yes, please. Yeah, so you said that a linear function is just a straight line. Okay, that's very great because that's one of the key concept of linear function. And how do we identify linear functions? So if I give you some graphs of some functions, let's say this one is y equals x plus 1, and the next one is y equals x squared, and the other one is x equals 1. So would you please tell me which one or which ones of those is or are linear functions? So do you please answer this? Yeah, so you think this one are linear functions? Okay, very great, thank you. Yeah, this one is indeed a linear function, but this one is not, because this one, although it's a perfectly straight line, it doesn't have gradient. So in this function, the gradient is undefined. So this is not a linear function, and it's not even a function. But today we will be only looking at linear function. So let's just see this function as an example. So if I ask you to find out the y-intercept and the x-intercept, would you please discuss with your pair that which 2 points do you think are the x and y-intercepts of this linear function? Okay, so finished. So can someone tell me what's the x-intercept of this linear function? Okay, so what's the y-intercept? Okay, so let's first let's look at what x and y-intercepts are. Okay, so x-intercept is basically where the line across the x-axis. So that's the point where the linear function crosses the x-axis, right? So this point will be the x-intercept. And it seems that the y-intercept is where the graph of the linear function across the y-axis. So this point here would be the y-intercept of this linear function. Okay, so my next question is that since we know which 2 points are the x and y-intercepts, how do we know the x and y coordinates of these two points? So when x intercept when is this point, so there is a obvious point, which is that on every point on the x-axis, the y-coordinate of them is 0, right? So it's 0 here. So how do we know what is x-coordinate? So when y equals 0, what is x equals to? So basically it's 0 equals x plus 1. So x should be minus 1, right? So x. So minus 1 comma 0 is the x-intercept. So the same y-intercept is where the x-coordinate is equals 0. So when x equals 0, y equals 0 plus 1, which is 1. So 0, 1 is the y-intercept of the linear function of y equals x plus 1. Okay, so you can just copy this down if you are still not sure about them. And if you have any questions, you can ask anytime. So next, when you finished all of this, would you please find out the points where x equals 1 and the next point is y equals 6. So would you please find out these 2 points which satisfy these 2 conditions? Finished? Okay, so for the first one, x equals 1 here. So what's the point of x equals 1? So when x equals 1, what is y equals 2? So when x equals 1, y should be 1 plus 1, which is 2, right? And when y equals 6, what is y equal to? What is x equals to? X equals 5. So there should be 5, 6. So do you have the same answers as here? Okay, very great. So since all of you have got that, we can move on to our next conception, which is the distance between 2 particular points. So let's say the points 1, 2 is roughly here, and point 5, 6 is roughly here. So if we want to know the distance, the length of the distance between these 2 points, how do we find out the distance? So any idea? Yes, please. Okay, it's very great, but sometimes this graph cannot be scaled, so we cannot just measure it using a ruler or something. There is a much faster way to do it and a more accurate way to do it. So how to find out the distance between 2 points which lie on a linear function? There is a formula, and the formula here is the distance d equals the square root of, so 1 here and 5 here are the x-coordinates of these 2 points. So if we use 5 minus 1 bracket, then squared, and plus 2 and 6 are the y-coordinates of these 2 points. So if we use 6 minus 2 bracket and then squared, and then we plus them together and then square root of it. So if we simplify it, it should be 4 squared plus 4 squared. So it should be 4 square root of 2. So that is the distance between the 2 points here. And this is the formula. If we generalize it, we can use, if these 2 points are not are limited to 1, 2, and 5, 6. If we see these 2 points, just x1, y1, and x2, y2. So the distance would be, sorry, square root of x1 minus x2 square root, not squared, and then y1 minus y2 squared, and then square root the sum of them. So that would be the distance between the two certain points on linear functions. Yeah.
So now you have known at least one way of working out the distance between 2 points. Now, I'm going to be introducing the second way you can use to work out the distance between 2 points on the plan. So before we start, I would like you to think of a magic triangle, which is this triangle. Can anyone tell me what does this triangle called? What is this triangle called? Yes, very good. It's a right triangle. A right triangle. So, is there anyone can tell me what kind of triangle is a right triangle? Why it is a right triangle? Yes, yeah, very good. Because one angle in this triangle is 90 degrees. Very good. Okay, so now I'd like you to take a look at this right triangle. Could you please tell me which side? As you can see, this triangle has 1, 2, 3, 3 sides. Which side in this triangle is the longest? This one? Yeah. Yes, so this is the longest side in a right triangle. And it has a name, a very special name, which is hypotenuse. Hypotenuse. So as you can see, the longest side, which is called hypotenuse, is always the opposite to our 90 degrees angle in this right triangle. Okay, good. Now we've sort of reviewed a little bit about the right triangle. Now, could you please tell me that there is a theory that we learned before, which has to do with a right triangle? Can anyone think of the theory that we learned before, and it has something to do with a right triangle? Can anyone tell me? Oh yeah, yeah, very good. So it is Pythagoras. Pythagoras. Am I spelling right? P-Y-T-H-A. Sorry about that. Pythagoras theorem. Okay. So, can anyone tell me what is Pythagoras theorem? How it is related to a right triangle? How they are related? Yeah. Yeah, very good. So, what is Pythagoras theorem? Is when we have a right triangle here, and let's just say one of the shorter side here, the length of it, this side is A. And then the length of the other shorter side is B. What about the then length of this hypotenuse? Is C. So, yes, very good. Pythagoras theorem is one of the shorter sides squared plus the length of the other shorter sides squared equals the length of the hypotenuse squared. And this is what we call Pythagoras theorem. You got it? Yeah, very good. So why we need this? How this Pythagoras theorem is related to our topic today about the distance between 2 points. So let's take a look at this. Now I would like you to give you the first question today. So let's say this is a plant, and we've got 2 points here. Point A is 1, 2, and then point B is 5, 8. So now, if we want to work out the distance between these 2 points A and B, here, how can we work out the distance between A and B? And by using Pythagoras theorem, can anyone think of a way of solving this problem? Okay, yeah, good. Yes, very good. So what I'm going to do is I'm going to draw a right triangle where the hypotenuse connects point A and point B. So this is hypotenuse of this right triangle. So how can we work out this distance? We simply need the distance of, yes, this side and this side. Let's just say this point is C. So can you tell me the distance between A and C? This is easy, right? And can you tell me the distance between B and C? It's easy as well. So take a few seconds to see whether you can figure out the distance of this and this. Yeah, please tell me. Yeah, very good. The distance between A and C, before we work out the distance between A and C, what we need is the coordinates of point C. What's the coordinates of point C? Okay, very good. When we like this, so should be 5, and then this is 2, should be 2. Yes, good. Now, distance AC is 5, right? This is 5. And then distance AC, this is 1. So the AC is 5 minus 1, so equals 4. 4, good. What about BC? What's the distance here? It's, yes, good, it's 8. What about this distance? It's 2. So this is 8. And then this is 2. Distance BC is 8 minus 2 equals 6. So we've got 6 here. now we've got everything we need to get the distance between A and B. Now we can say that AB squared equals, what do we get here? 4 squared plus, yes, 6 squared. So AB 4 and 6. And you can simplify it yourself. So yeah, we've done our first question. Now, you've worked out this question under my help. Now, I'd like you to give the second question and to see whether you can work out the second question yourself. So now I will give you 2 points as well. Point A now is -1, -2, and point B -3, -8. So now spend a few minutes to see whether you can work out the distance between A and B this time by yourself. Okay, so that's the end.